So today we're going to talk about trinomials with common factors. And if you remember from what we talked about in lesson 69, we had to factor something like x squared plus 3x minus 10. We had to factor that out. And if you remember, our first step was to put these parentheses in here. And then we need to factor out what each one had in common, and then basically create the backwards version of the FOIL method. So we start off with both x's, because when we multiplied the x's together, we had x squared. Then we factored out our 10, and we got to figure out what plus or minus out of the factors of 10 is going to give us 3x. And so we knew that 5 and 2 are going to be, since 10 factors out to 5 and 2, we came up with 5 and 2. Now we just had to figure out what our sign was. Since our middle number here is a positive number, we're going to take that larger sign, which is 5, and make that a positive, make that one a negative. So now we have x plus 5 times x minus 2. So today, we're going to work on doing the exact same thing here, except we're going to factor something out and then put that into the same thing. So we're going to take, for example, x cubed plus 6x squared plus 5x for our first problem. Now, we look across here and we see that we know that each three terms has x in common. So we're going to factor out the x. Just like we have on the previous test before, we've done the exact same thing. So when we factor an x out of there, we're going to do like we just on the test. We're going to see what times x can give us x cubed. It's going to be x squared plus what times x gives us 6x squared. It's going to be 6x plus what times x gives us 5x. We see that's 5. So now that we factored that out, we're going to take this and factor this again. So we're going to have x here. We're going to put our parentheses in just like we did in the previous problem. And we're going to start off, we have x here. Because x times x is going to give us x squared. Our factors of 5 are 6 and 1, or excuse me, is 5 and 1 and 3 and 2. So we're going to go ahead and see that when we add 5 and 1 together, we're going to get 6. So we're going to put 5 here and a 1 here. So we look at our sign, we see that both our signs are positive. And so our final answer is going to be x times x plus 5 times x plus 1. So let's take a look at another example here. We're going to have 4bx cubed minus 4bx squared minus 80bx. So when we look at that, once again, we're going to see what each of those have in common, what we can factor out of that. So we see that each one of them has a bx involved. So we know we're going to at least factor out a bx. But there's one more thing we can look at that they all have in common. We have a 4 here, we have a 4 here, and we know that 4 will go into 80. So our other common denominator, common factor here, is 4. So now we're going to take what times 4bx is going to give us 4bx cubed. And we see that's going to be x squared minus what times 4bx is going to give us 4bx squared. And that's going to be x. Take another minus. And then what times 4bx is going to give us 80bx. And we see that 4 goes into 80 20 times. So now we're at this point now. Now we're going to factor out x squared minus x minus 20. So again, we're going to write out our 4bx. Create our parentheses here. We'll start off just like we do with all of them. And we're going to put our x in. Now, when we factor out 20, 20 is going to factor out several different ways. It's 20 and 1, 10 and 2, 5 and 4. And when we look at which one of those is going to give us 1 here, we see that 5 and 4 is probably going to be our best answer. So we're going to put a 5 here and a 4 here. Now the tricky part, again, is going to be which sign is going to go here. We see this is going to be a negative sign. So since this is going to be a negative, we're going to put that as our largest sign, which is here for -5, make this a +4. So our final answer is going to come out to 4bx times x minus 5 times x plus 4. So let's take a look at one more example here. We have a -3x cubed minus 6x squared plus 72x. So once again, we see that we can factor out something out of all this, and we're going to take at least an x out. And we look here, we have a 3, a 6, and a 72. So we can see we could take at least a 3 out of this, a 3 out of this, and a 3 out of the 72 as well. So we have a 3x. let's take a look one more time here and look a little bit closer. We have a negative here, and then a positive. But we know that we can multiply two negatives to make a positive. So we're going to be able to factor out a negative 3x out of this entire problem. So now, once we've done that, we could say what times negative 3x is going to give us negative 3x cubed. And that's going to be x squared. Then we're going to take a minus. What times negative 3x is going to give us 6x squared. And that's going to be, actually this would be a positive 2x. And then this will be a negative here. What times negative 3x is going to give us 72x. And that's 24. So now that we're to this point, we see that we have negative 3x times x squared plus 2x minus 24. Now we're just going to factor out the x squared plus 2x minus 24. So minus 3x, open up our parentheses here. Again, we're just going to go ahead and put in our x's here. And we're going to figure out what the factors of 24 are. So we know the factors could be 1 and 24, 2 and 12, 8 and 3, 6 and 4. And we see that probably the best solution to get an answer of 2 when we add or subtract those is probably going to be 6 and 4. So we'll go ahead and put a 6 here and a 4 here. And we know that by looking at our signs, we're going to have a positive and a negative in there. So again, we're going to take our sign of our large number here, because this is going to be positive. We'll put a positive here and a minus here. So our final answer is going to be negative 3x times x plus 6 times x minus 4. So also in this lesson, we're going to talk about subscripted variables. So we've looked, in the past, we've had, a capital N is going to be, it represents some type of unknown number. But we've also used x and y as variables in systems of two equations. So you remember when we've had things like, 5x plus 10y equals 125, and x plus y equals 16. We've obviously seen that x and y are going to be the variables in this matter. So, but now this time, we're actually going to look at a problem that's going to have something that looks something like this: 5 capital N capital or little n plus 10 capital N D equals 125. And then we'll also have that the D equals 16. So these are called subscripts. So you can see here, we still have basically the same problem, but we have subscripts instead. And so we'll go ahead and show you how to answer this problem here. So we look at our example here, and this is the exact same example problem that we just wrote up here. And if you remember, when we wanted to take these before, when we wanted to eliminate something, we multiplied something from the opposite of something on the top, and we multiplied it to the bottom to cancel something out. So in this case, we have a 5 here, and we're going to try to cancel that 5 out. So in order to cancel that 5 out, we're just going to multiply the bottom here by negative 5. So when we multiply the bottom by negative 5, let's go ahead and rewrite it. Oops, this is an n. Plus 10 nd equals 125. Then we multiply the bottom here, we're going to get negative 5 n plus negative 5 nd equals negative 80. So now that we've got that, we'll just go ahead and we see that we can cancel out here, and we're going to be left with is 5 md equals and then we subtract the 125 minus 80, and we're going to get 45. And just like we would with any other problem, we're just going to divide both sides by 5, and we're going to get equals 9 now. So now that we see that, we'll go ahead and substitute that back in up here to see what we get for our notation of n is, or a subscript of n. So we go ahead and put this in here. We're going to get, we'll write it down here, I guess, n of n plus, put in our 9 equals 16. And we subtract that, we're going to get n equals 7 for our final answer.